RBS Based Research Academy welcomes you in the lecture number 44. In this lecture number 44, we are trying to understand the two-stage approach, the concept of two-stage approach, and how to perform the two-stage approach in SmartPLS. Two-stage approach also includes the two approach basically. The first one is the disjoint approach and another is the embedded approach. So these two approach and their concepts we are also understanding in this video. There are the two parts of this video. In the theoretical part of this video, we are understanding the concepts of the two-stage approach, disjoint approach, and embedded approach. And then in the practical video, we are going to apply these approaches in the SmartPLS-4. So I would like to remind you that this is the part. It is another video on the higher order construct series. So now this is lecture number 42, 43, and this one the 44. These three lectures are so far the part of the higher order constructs. So let's start to start this video formally. But before this one, my name is Dr. Sumuro, and I'm working as a professor at the Shah Abdi University, Pakistan. Here, the certificate which was awarded to me from the SmartPLS Academy, Germany. Dear friends, when you talk about the understanding higher order constructs, so this paper is a very important paper. If you want to understand the some of the details about the higher order construct. Even though whatever the videos, whatever the PPTs which I have prepared, this is the best paper from where the ideas which I have extracted from this paper, and then I have prepared all these videos. So I strongly recommend you that along with watching my videos, you also go through this research paper. In order to download this research paper, I have left one link below this video from which you can download this wonderful paper. Now, when you talk about the two-stage approach, so what is two-stage approach? Basically, there are two stages are there. In the first stage, what we estimate the model without the second order construct. So here we are not inserting any second order construct, but we are working on the first order construct where we want to check where we want to assess their measurement. That means assessment or measurement model we are performing at the first stage. In the second stage, now what we will get the latent variable score, and then we will make them as an indicator of the second order construct, and then we will estimate the parameters. And then here the two approaches are there right now: embedded approach and the disjoint approach. In the two-stage approach, now in the first stage, what actually we have to do, that we have to do like this. We have to check the reliability, and we have to check the convergent validity. We have to check the discriminant validity. In the reliability, we have to check the Cronbach alpha and the composite reliability. And then in the convergent validity, we have to check the factor validity and the average variance extracted. And in the discriminant validity, we have to check the Farner-Larker criterion and the HT-MT heterotrait monotrait test. So when we talk about the measurement of the assessment of the measurement of the model, then we have to check basically two things: reliability and validity. Either our model is reliable and valid or not. So these things which can know at the stage number 1. So now if all our the values are in the green color in our SmartPLS, then we should be happy that there is no any problem with our model. And then we are next one. So now the embedded two-stage approach, what's happened there? So now we have to save the scores of all the constructs in the model, and then add these as a new variable in the data set. First of all, we have to get the scores. So in the SmartPLS-3, there was the scores which now when we have to get the scores will be given in the Excel file. So now, and then we have to attach the new Excel file with your SmartPLS-3, but now it is very easy than SmartPLS-4 because all the values are automatically computed, are saved in the new file along with your old file or your existing file on which you are working. So how will you get the scores and how where the score will be saved? If you watch the practical part of this video, then easily you will understand these things. Construct scores are used as indicators for the higher order construct. Then these construct score we will use as an indicator of the higher order construct, and all the construct in the model are measured with a single item that captured the construct latent variable. So here every item has a single the construct has a single item, or we can say single item construct. And then in the disjoint two-stage approach, what does we have to save the construct score, but only of those lower order component. Now, like this, these are the lower order components. Their scores we have to save first of all, and then stage number 2, these scores are then used to measure the higher order construct. Then we have to measure these for the higher order construct from these like the scores. And then the difference basically between the disjoint approach, the embedded approach, the difference. So different from the embedded stage at the approach, all the construct in the path model are estimated using the standard multi measure in the one stage. At the first stage, our construct have a multi items, but in the second one, if we apply a structural model with some construct and latent variable composite score and some with the original raw data. So what's the main data in the disjoint approach? Some of the construct we have the single item, and some of the construct which we have the multi-item construct. So this is the actual difference between the disjoint approach and the embedded approach. So now I'm giving example to further understand the difference between these two. One, for example, you are looking here, this is the latent variable score. So here you are looking at the this variable, there's only one indicator and only one indicator and the only one indicator. So this is our higher order construct. These are lower order construct. So there are 3 constructs, and every construct has only one indicator. In case second case, you are looking data in this one. So now this is the basically the disjoint approach. So here disjoint approach is like the combination of the measured variable and the latent variable. How in the latent variable, this is the lower order construct where only one item is there. Lower order construct only one item. It's the same situation here. And this is the higher order construct. But in case of the measured variable, higher order construct, and then in the this is the construct, just construct. So it has the 3 items. This means a 1, x11 to x12. So these are the, this one is a multi-item construct, and these are the construct, but these are sub construct, and these are the single item construct, and this is their higher order construct. So this is the difference between the disjoint and the embeddedness. In the disjoint, always we have the mixture of the measured variable and the latent variable score. Okay, so now we are going to enter into the SmartPLS in order to perform all these approaches practically in the SmartPLS-4. So now we are on the beautiful interface of the SmartPLS-4. So here you're looking, this is the project name, two-stage project. This is the project model, and this is the project data file where the 384 records are there. So now we are double click opening this one, and this is our model. So here this one is a higher order construct. So now first we are deleting this one, and directly we are measuring the assessment of the measurement model we are performing without the mediator, because without the higher order construct, because in the stage the so here is our model. So in this model, you're looking here, there's a these are our independent variable. These are our independent variable. This one also, and this our dependent variable. Independent performance are endogenous variable. So here. As we know, in the two-stage approach, in the first stage we have to assess the measurement model. So how to assess the measurement model? That's very easy. Just go into the SmartPLS and then press OK, and then there's a very pretty good R square, and then if we go to consider reliability, there is no issue because all are in the green color and all are above their a benchmark, so that's why all values are in the green color. Discriminability, again, there is no any issue because all are below the range of the 0.9. And the collinearity, again, these are some of these are in the green, some are in the black, okay, and some are in the red color. So now the difference among all is this one, that if the value is up to the 3, then the software will show you all the values in the green color, and that's good. And if those are from 3 to 5, then those will be shown to you in the black color. Again, that's good because some of the statisticians are of the view that the value of the 3, that's good. Others say no, up to 5, that's also good. But others, they are very generous. They say even up to the 5, up to 10, if the value of any indicator vi value is 10, again it's okay. But 5 looks good, justified. That's why this software also consider 5 up to the mark. So above the mark, those will be shown into the red color, and these are the violations. So now we have to remove. So above generally we can say that okay, that's okay, good set. So now we have check out the measurement model, and then okay. So again we are applying the okay. So here we are removing the direct path, and what that we are putting the sum of the higher order construct over here. So now in the higher construct we have to name it entrepreneur dimensions. So okay, so our dimensions have been created here, and then we have to give it the proper place, and then we have to connect, 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 and connect, and connect. So again, we want to check its measurement model measurement after adding the higher order construct. Then okay, and see okay, the problem is there that your path model is invalid, and please take a look at the red element. So whenever there will be issue, you will get this type of the warning. So now here this is a problem that the latent variable indicators are not available. So we have to assign the latent variable indicators, of which we have to start from the input skill, because our first exogenous variables is input skill, market orientation, and set, because they are connected with each other. So these are directly connected. So from this one to this one. So when you select all these one, you will also their corresponding item have also been selected here. Just select and drag and leave the assign this one, and those have been assigned. And then what we have to go and save it, and then again open it, and then now we have to hide this one in order to avoid the complexity. So now again the same smart PLS algorithm. So you are looking here again, there is no any problem here in the construct reliability except this one, because this is our direct path. This is a higher order construct, so there will always remain insignificant, and their R square will also be very high. So okay, how not high but 1. So here this one is a non-significant, and this R square is a 1. So that's why it's non-significant. Now again going to the report, and we have to take its latent variable score. Here latent variable score is available. Previously what we were doing that we were copying this Excel file, and then we were opening the whole this latent variable score, the Excel, then we were saving it, then we were attaching another data file with this one, and that's why we were able to apply to work on the latent variable score. But now in SmartPLS-4 this has been solved, and then what we have to create a file. Okay, and then this is the project name, and this is the file name. If you want to edit it, you can also. And right now we need the manifest variable score and latent variable score. Other variable score are also available. If you click, then their score you can also get. But we are not interested so far. We only want to get the latent variable score of these two ones. Create the file, and the file will be created. Okay, so now you're looking here. Okay, save it. Now you're looking, the two files are there, the records are same. So now write file, this is the latent variable score, and this is our actual data file. So now you look here, so these two files are looking so now these are our latent variable score, and this is our actual file where the latent variable scores are not available. So now we have to work on the latent variable score. So first of all, what we have to replace all these ones. So intermittent skill replaced with the latent variable score entrepreneur skills. Okay, and then it's better to delete the variable score and just click it. Okay, and then it is better also to delete the unnecessary thing here, and market orientation, delete it and select the market orientation. Okay, and then remove latent variable, and then again remove here the latent variable score for the market orientation, and then change its align it on this side. Okay, and then in the mark sales orientation, delete it and then bring the sales orientation here, and do the same thing with this one. Okay, and latent variable. Okay, this one also apply, and then again. Okay, and then market interpret competence. Now here is interpret competence. Select and drag it here, and delete these unnecessary thing, and then okay. So now these are our, and then interval performance we have also to delete and then bring it here, and we have to give the same treatment. Okay, and then same treatment with this one. Okay, and last but not the least, network, and that work, bring it network here, and okay, now and then select and then do the same thing. Okay, so now we have created all the, we have replaced all the variable with the latent variable score, then connect it. Okay, and then we are connecting it, connect it with this one, connect it this one, and then connect with this one. So now our model is ready with the latent variable score, and now we want to apply the bootstrapping with the 5000 sample. So now our effects are there. So the path coefficients are there. So almost all are significant except this one, because here we want to check the interval performance on the interval dimension. So this is a direct relationship. This will always remain insignificant because of the R square is 1. The rest of they are somehow they may be significant, but somehow they somewhat they may be insignificant here. So luckily, all the let me say path, direct path, indirect path, they are significant. Okay. So now we have worked with the latent variable score. So here you can also make the more connections like this one. You can take this one. Okay, so automatically the bootstrapping will run over there. You can also do this one. Automatically the bootstrapping will done. So now you can make so many it's so much complicated. Even you can do. Okay, and can you do this one? Yes, we have done this one. So these are so many paths are there. You can check out all these paths by opening this report, and then you can go through their different paths are there, and then these are indirect path, and then specific indirect path, total path are here. So now, okay, so here. Up to now, what we have done that we have we can say that up to now that means an embedded approach we have done. So right now we have done embedded approach. That means there are two approaches are there. One is an embedded approach, and then another is a two-stage approach. So now all these things we have done, and now what that are our variable, they are the latent variable scores, latent variable score they have taken from latent variable score, sorry. And then now what that okay, this one also and this one, this effect also. So okay, our model has become very simple model as it was earlier. So now what here the embedded approach has been ended. Now I'm going to work now on the another is a disjoint approach. How to work on the disjoint approach? That is very easy, because all these are latent variable score, and they have the one indicator latent variable. This one is a one latent variable is indicator. Now we have to attach the multi indicator variable latent variable. How? Interval competence, we read it, and you have find out interval competence. This is interval competence. Okay, bring it here. Okay, and then now, and then another network, we have also delete the network, and then okay, go down. So this is our network. Select it, and okay, and drag it here. So now here, so now we have to connect with these two one with the same one, and okay. So now here this is called the disjoint approach. So why disjoint approach? Because some of our variable like these are with the single like the indicator, and these are the multi-indicator skip. So that's why this is called the disjoint. In the embedded approach earlier, there was all the variables were with a single indicator. So that's why this is a disjoint. It means a model is not joined with each other. That means some of the variables are with a single indicator and others are with the multi-indicator. So again, we have to apply bootstrapping with a 5,000 sample. So bootstrapping has been applied, and then you're looking the results are here. So here you can also do the same thing with this one. You can make it more complicated. You can connect the different like the path over there, and you will get the more results over here. So now whatever you want to do, you can do with this one. Okay, you can do this one. You can also, okay. So you can do all this one. Okay, and you can also check the impact of this one. So whatever you want to do, so you can check that. So now this is the so many paths are there, and the same way you look here that our path, so many paths are there. The results are also there. Indirect, direct effect, total effects are here. So now this is the here we have completed our work on the disjoint approach. So if this video has served your purpose, so please you are requested to subscribe my channel and to leave the comment and to refer this channel to your friends. Thank you very much for watching this video.